With that nice introduction to HPC systems. So I guess that we are more motivated than we were in the morning to learn more. So we finished this part. So until 10, where we'll have a break, we'll have a look at how we practically work on HPC systems. So me, Maiken and me, we're going to go through this. So as usual, while we talk about this, please send the questions, and if you have any questions on the HackMD, not in the Zoom chat, for example. One thing I forgot to mention was that I see that some new people are here who were not yesterday. They were not here. That we have this code of conduct that when we ask questions, even on the HackMD, we have to be polite and considerate. And the other thing is when you are not in an exercise room, don't on your cameras, which will make the video processing easier. So during the exercises, you'll get a chance to open the camera and open the mic and ask questions. So we'll move on to this one. First, we had a look how the HPC system is, the difference between servers and etc., and the use cases of it. In order to use these HPC systems, you need a user account. All of you here, we expect that you already have a user account, active user account, and password that you are ready to use. So this link is there in the teaching material here as well, for the completion of the lesson. So if you want later on come and check again, the links are here. Then I would like to point out that some tabs in this teaching material. We are trying to consolidate all the HPC systems in Norway, so all the staff can contribute to one lesson. So not all the tabs might be relevant for what we going to show on the system called From today. So if you're following some on some other system like Fox, so you should use the correct tab. And later on, when you see separate tabs of Saga, From, and Betsy, please make sure that if you're going to follow what we do, you use the From tab. Please also have in mind that Saga system is down at the moment, so trying to log into that would not make sense. It will not work. As we discussed slightly on the day 0, that this paradigm shift that we're going to talk about is that we have been working on our laptops or servers. So that is our basic expectation from you, like you might be already working on HPC systems, but we start from the point that we are working on a computer that's in front of us, that we type with a keyboard and we see the output on a screen, or get a printout from printer, or a image that we view. But now we are going to work on something on the other side of the network, which is not in front of us, which can be on the other side of the internet, or maybe it's something that's on the other side of the university network. In order to reach this, you might have to send some signals through the internet or the local network to the cluster, and then get some feedback onto your laptop. So you use your keyboard on your laptop in order to control something remotely. So certain things that we do might not be very obvious certain times, but having this concept in mind that your keyboard, when you press a key, that execution actually happens somewhere else, might be helpful. That's why this diagram is there. So if you remember what SSH was, it is a protocol that makes sure that a protocol in the a protocol means established set of rules. There are some rules that how you do this communication and how to do it securely, so you don't get hacked, or your operations and your data transfers are secure. So the first thing is that I want you to type with me. I want you to try with me that the terminal that you have. So if you don't know what your terminal is, if you're not here yesterday, please ask in the HackMD and you will get some help. Open the terminal and type SSH with a minus or a dash, you call it, and a V. So I'll make the font a little bit bigger, so you will see more. And V and enter. And our colleagues, can you please post this survey while this being done, that they found SSH. So on the HackMD, please start a survey that I have found my SSH and it's working, and or that I have issues. So if you get this message, so this version and the other details are not comparable. They will not be comparable, may be comparable, but you don't have to compare them. Only thing you have to see is that you don't get a message like command SSH not found, which means you can't go beyond this lesson with the practicals. You could follow it with us, just listen to what we say and follow it later. But this command should return this some non-error output in order for us to continue. I'll just check the survey. Yeah. So in the next 1 or 2 minutes, if I don't see any no's, I will go forward. If you have a no, then you have to get help, and our staff will help you. Yes. Let's see. I think it's mostly okay. Yes. So as I slightly mentioned in the beginning, because Saga is down, we are following the from tab here. So because these are tabs, trying to sort of generalize the process. If you want to move to other system, you could also do that later on. Let's say if we learn how to do it on from, you could compare, how you would go about doing it in Betsy or Fox. Fox slightly different login process because it has two-factor authentication. So you could also compare that later on if you're on a different system. But the from is the one I'm going to use it today. Before we start, I'm going to use a command that we used yesterday. The host name. Sorry, I need to log in first. Sorry, right? Did I log in? Yeah. Yeah. Host name. So in this computer, I typed the spellings wrong. So this machine, which is like a container I'm running, so it has this non-trivial name. Then what I would do is I'll try to log into from SSH space my username. Don't use my username. You have to use your username that you got. Then the @ from .sigma2.no. So that is the address of the machine. So when you press enter, you will be asked to verify a key. So this means that you have not been logged into from before, and this SSH, that machinery, want to make sure that you mean to connect to this server, that you don't type something accidentally to connect to some malicious place, that you mean to access this place. So it gives you the key to compare it with from. So you could compare it with from as well. So our colleagues, please, if you can find the place where we list the keys for our login nodes, paste that link on HackMD as well. Here I trust this. I know this key is correct. I'm going to say yes. Then it will ask for the password. Then I will give you my password. When you type the password, you will not see it. It's invisible, but it's being typed. So after typing the password, I'll give you some more details about it. So I type the password here, request success. And I am in this from login node. Then I could use the same command, host name, and I'm in this machine. So you should see the name from in the host name. And login one is not, you might not see, you might see a different login node because there's some load balancing going on. When many people log in, they can use different login nodes. So you should come here. So another survey to see whether you have logged into a server. If you're going to follow it on Fox, you could do that as well. Another survey to check that you have logged in. So this you need in order to proceed. Okay. So please go ahead and try to log in and try to get this prompt. Use the command hostname to verify that you have landed on the correct machine. Yes, so thank you. Our colleagues are helping you with this thing. So the SSH, there's a space and a dash, and there's no space between the capital V and the dash.
Yeah, so it all looks good, I think. Seems like people are logged in. There's one no.
Okay, the person who said no, please ask a question about this, alongside that questions, and give the reasons, why you couldn't, and then we could check. We could see whether we can fix it now. Otherwise, you could follow what we do. Now, Maiken, that I want you to, or our learners to follow me, not type along. When it's time to type again, I will let you know. So when we logged into this machine, one thing that we will have is the home directory. That is a place where all the users get on our clusters, that when they logged in, they have a place to keep their files, not to keep all the research data. For example, there are other places for that. A personal area for you to use. Certain installations might use this, like PIP, for example, might use this location. And you will place files, and if you don't specify a path when you transfer files, those files might land here. So the command we learned yesterday, PWD. So this should give you this your home area. So after I logged in, I actually, when my result gave me something else. So if that happens, you could use that command to come back to your home, CD. That means you come back to the home, then type the PWD to make sure print working directory to see your home directory. So how it looks on different clusters might be different, but the command is the same. Then there are some basic files in your home directory. This will not be comparable with your home directory. And if you remember, Maiken, we learned about these options. Yesterday we learned about list, and now we have this A. Do you know what this A stands for here?
Yeah, it's all, I think, and so it'll show also hidden files, the
Hidden
dot files.
Yes. So if I just use the A, it'll also show these dot files. For example, I have the SSH directory, which stores certain this SSH stuff, and some Emacs and some Conda, and this local directory where I will have my pip files. All these are here. But if you don't use the A, you will not see that. Then we'll talk about something about the setup of our system. So we were on our laptop, we used the internet, and when we logged in, Maiken, then this login node, this is not really the HPC system. That means we are in a login node. What kind of things that we usually allow to do on a login node, Maiken? Do we allow to run a big simulation on it?
Yes, this is
How
very
do we do
important kind of how to behave on a big HPC system. So when you log in, you end up, as Sabry said, on a login node. And those login nodes are not for running heavy computational tasks. So there is information about this various places, but it's also important to mention it here. You can try to run your code like a little test sample, just to check that everything's working, but do not start your full simulation or whatever analysis you're doing on the login node, because that means that you'll use all the resources and nobody else will manage to log in.
Yes, so in a shared resources, some housekeeping and some good ethics are also very important in addition to doing your analysis in a good way. So we learn in the next lesson how we actually recruit our computer farm in order to do our analysis. So you logged in here, and then you give the job to the HPC system or the cumulative supercomputer that we're going to talk about. And Bjorn mentioned slightly, we have different names for these things. So we might also use these different names. Some people call this head node or login nodes, and all means same thing, but different people might refer to this as different nodes. So these are computers that actually do the heavy work. They are referred to as compute nodes, yeah, there are other names here that might be used. So worker nodes, for example, there are other names given here. So this typing also I'm going to show, so you could practice this when you have the session. So I just want you to follow this one, not to type along here. Once you logged in, this computer farm here behind this login node, we can have some information about it. Now we are going into this HPC specific, or this more like Slurm specific that we're going to check later what that is. Commands. So we have this command called, I'm going to clear the screen a little bit to get some more space, and type this command sinfo. But when I type sinfo, because we have 1,000 computers, about 1,004 to be exact, I think, it'll print a lot. So here I typed the command here sinfo, and it typed a lot. So these names C3-8 means the number 8 computer on the rack 3. So they have specific numbering system here. Here, this one, which means C23- within square brackets 3 to 11, means there are 3, 4, 5, 6, 7, 8, 9, 10, and 11. So they are shortened. This is short form to mention there are many computers mentioned here. And you will also find some partitions. Some are called normal, which use for normal computation. And then we have the big mems with more memory. So big mem, if it is C8-1, you have more memory. And this we have another partition for optimist, which we'll talk about a little later, that you could run jobs, but if somebody else want a priority, you have to give them away, give them way, and then come back to it. Then this Corona machines. Maiken, remind me to talk about this a little bit when we come to the scheduler about these reservations.
Okay.
And this course machines. So this is a specific machine that we reserved for today's course. That information is useful as well when we run the jobs. So this sinfo is the command that we use to get details. You could also get information about a specific machine. For example, let's say C8-1 if you use the -n and the machine name, it will give the specific details. So you could have a job that could take up to a week in that machine, or if it is because it's a big memory job, you can take up to 2 weeks. Then we have more information that we can get. So what is a node? So the node is, this computer look like a pizza box. They are racked, they are stacked onto something called a rack, and connected with a high bandwidth, high speed network, so they can work as a single unit. So when you take them apart, you will find some main units inside. You don't need to understand everything inside in order to run a job, use it for your processing, but a basic understanding would help. There are CPUs, for the processing, and there's memory for the temporary storage, and a local storage on that machine for storing, use it as a scratch area, for example. We'll come to the network storage a little later on. So everything in the memory will be used for temporary storage, and this is for more permanent storage. And when we refer to cores or tasks, the processing units, they happen inside the CPU. So if you had, if you could, had the opportunity to visit our sites, you could see one opened up computer. Then I'm not going to. So this next one is to compare your laptop's resources to the HPC server. The main motivation in that is to show you that the HPC one node, one computer in the HPC system, it's not that different from your laptop. It could have a lot of memory. It could have more cores, but it's not considerably very different from what you have on your laptop, because these days the laptops also have 18-16 cores on them as well. To give more of a motivation for later on, that if you want the real use of this HPC system, you have to recruit more than one in your job, for big jobs. But some of the machines, they would have much more memory than you can have on your laptop. So we'll explore a little bit the system itself, not the laptop, because the laptop commands given here would only work on a Unix system. On my computer it will work, and you might not be. It might not work on your system if it's not Unix. So nproc is to give a number of cores. A number of in these processors, they have smaller units inside. So one of them could have many cores inside. So on we have a 2-circuit system. That means there are 32 cores inside one of these. So both of them together would have 64. And then the memory, use the command free m, which gives us that it has about. So it's hard to read the human. It's had on human readable format. It has 128 gigabytes of memory. Your laptop might have more sometimes, maybe if it is a powerful machine. So before we go into this, I will show you one of the big mem nodes as well. So this one that I showed you before. Don't try to do this on your side because this SSH would not work for you unless you have a job in that. So I'm going to demonstrate that here. I'm going to go inside this machine. That is this C8, not the login node. If I ask free.
So now you're actually on the compute node where you are running your job.
Yes, yes, I'm inside that just to check the memory, just to show you that there's a lot of memory. Then I will get out of it. So later on, we'll see that, you know, the different machines have different memory requirements. So if you want a big memory job, you need to use the big mem. Now in this one, what we're going to focus is this shared storage, Maiken. So if you placed files on this shared cluster storage on one machine, if you place it on the login node, it will be available for all the compute nodes and also the login nodes. So you don't have to copy everything everywhere. So you copy it one place and it's be available for everywhere, all the processing. When you, yes, Maiken.
Yeah, I was just going to say, sorry, that it's a bit like your home area when you log into a system like the UIO account or your Tromsø account, or, you know, when you log into the system, university systems, you will have your home folder, which will be the same basically wherever you end up on what login nodes you end up.
That is a very good point, Maiken. And in fact, the home area is also on the cluster file system on from. So the difference between these nodes are basically the amount of memory. Some of them might have GPUs for GPU processing. On from system, we don't have GPUs, but on Betsy and Saga systems, we have GPUs. And the amount of power they have. Maiken, what I'm thinking now is that if you don't have anything to add in this, we'll have the break now. And then let's see how our time is. Okay, let's go to the events. So we were going to have the break at 10. Okay, now we are right on time, Maiken. Yes, now we can go for the break now. And on the HackMD, we can mention this as well. The break is until 10:05. If you have any questions, please come place them on the HackMD. Anything else to add, Maiken?
No, I think that's fine.
Yes.